What if I tell you that we can find the net resistance of this circuit in less than 5 seconds? And the answer would be 8 ohms. Let's find out how. This is a circuit where all the resistances are in series. Before we solve it, let's find out how to determine if a circuit is series or not. We have this battery. We see this positive terminal and the negative terminal. Try to show the flow of the current starting from the positive. I will assume that the current is I. So the current I is coming from the positive terminal. The same current goes here because there are no obstructions on the way, so it will keep flowing. Eventually it will go here, the same current. It goes through the first resistor and comes out. So through the first resistor, it was the same current I. It comes out, goes to the second resistor, same current I. The same current I comes out. Then I is here, I and I. Notice that the same current is passing through every point on the circuit. There is no break. Circuits like these are called series. For circuits in series, the formula for net resistance, R net, is R1 plus R2 plus R3. And if there are more, you can just keep adding. So in this case, R net would be sum of 3 ohms, 1 ohm and 4 ohms, which is 8 ohms. That's the net resistance of this circuit. What it means is that instead of using 3 resistances, 3, 1 and 4 ohms in series, we can replace them with one 8 ohm resistor and you will still have the same effect. So we have 8 ohms and the same voltage, 16 volt. This is your simplified circuit. This circuit has been simplified as this. Now, one of the basic formulas is Ohm's law. V equals IR. V is the voltage, I is current, and R is the resistance. From this circuit, voltage is 16 equals I, current, which we don't know, and R is the resistance, which is 8. From here, to find I, we divide both sides by 8, and 16 divided by 8 is 2. So the current is 2 ampere. The unit of current is ampere. Now if I go back to my original circuit here, this I was 2 ampere. 2 ampere is flowing through here, 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 and throughout the circuit. In this case, let's assume that this is resistance R1, this is R2, and R3. The current passing through resistance R1 will be called I1, which is same as I, 2 amperes. So I1 is 2 ampere, I2 is also 2 amperes, I3 is also 2 amperes, because in series the same current passes through all the resistors. Using this formula V equals IR, you can find the voltage across all the resistors. For resistor R1, the voltage V1 would be equal to I1 R1. When I am talking about the voltage of resistor 1, I will use all the values for resistor 1, I1 passing through R1, and the value of resistance R1. I1 is 2, R1 is 3, so it's 6 volt. V1 is 6 volt, V2 is I2 R2, which is 2 times 1, 2 volt, and V3 is I3 R3, which is 2 times 4, 8 volt. This is how you find voltage and current through every resistor in series. If you understand this, can you try this circuit? Here you have only two resistors, 2 ohm, 7 ohm, and the voltage is 18 volt. Consider this as R1, this as R2. Find the net resistance. Find the current passing through the first resistor, I1. Find I2 and find the voltages through both the resistors, V1 and V2. And write your answers in the comment below.